Section 4.6 deals with functions. And we're going to see how they relate to what we've been talking about. So a function is a relation, and remember a relation is a pairing of values, x and y values, in which each element of the domain, that's our x values, is paired with exactly one element of the range, the y values. So we can have relations, and I'm going to do one in table form. Remember, we can show relations lots of different ways. So 2, 3, 6, 1, 7, negative 2, 8, 1, and 4, 3. Each element of the domain, 2, is paired with one and only one y value. Even though the 4 and the 2 are both paired with 3, they themselves are only paired with one element. So this is a function. If I were to add another ordered pair where 2 might be paired with something else, say negative 1, now I do not have a function. So again, a relation is a function, a pairing of numbers, where each domain value or x value pairs exactly and only with each range value, only with one range value, sorry. So there's lots of ways to show this. If I did a group of ordered pairs, 2, 7, 3, 6, 4, negative 2, 5, 7, 3, 4. This is a relation, a pairing of x and y values. However, it is not a function. See if you can see which ordered pairs cause this to become something that is not a function. All right, so the 3 here, which is part of our domain, is paired with 2 different values. So those 2 ordered pairs are what cause this to be a relation and not a function. And again, if I eliminated one of those ordered pairs, now I have a clear function. Okay? All right. Sometimes we can also tell if something is a function by using a vertical line test. We do this when we have a graph. So if I have a graph of some ordered pairs, say 1, 1, 2, 3, 3, negative 1, negative 1, 2, negative 2, 3. This is a function because if I draw vertical lines, go back and let me use a different color. If I draw vertical lines through this function, each vertical line goes through one and only one point. Now again, if I were to add an ordered pair, such as 1, negative 1, in other words, the ordered pair 1, 1, and 1, negative 1, where this domain value of 1 is paired with 2 different y values, then my vertical line test fails because the vertical line that goes through 1, 1 also goes through 1, negative 1. We can also do this with graphs of more traditional functions. For example, a function that looks like this, that is a linear function. This also passes the vertical line test. Every vertical line crosses my function in one and only one spot. Let me show you a function that would not be, or a graph that would not be a function. So if I have a graph that looks something like this, this graph is not a function because you can see that over here my vertical line test works, but there are several vertical lines in here that cross the graph in more than one place. In other words, they have ordered pairs where the same x value, let's say this is 3, 2, and this is 3, 4, and this is 3, negative 2. The domain value of 3 has more than one range value attached to it. Okay, if you have any questions about this, be sure you mention it so that we can talk about it at the beginning of class. Okay, so functions can also be written as equations. So for example, y equals 3x minus 1. How do I determine whether or not this is a function? There's two ways to look at this. One is to use a little bit of common sense. If I set up a table of values, no matter what x value I pick, there is only one possible y value that can be obtained from this function. So if x is 2, the only y value could be 5. If x is negative 1, the only y value is negative 4. So this is clearly a function. The other way would be to look at the graph of this function, and it is in fact a linear function. We'll learn more about ways to graph it, but we've already looked at this a little bit. So 2, 5 is my ordered pair. 2, 5 is an ordered pair. Negative 1, negative 4 is an ordered pair. And this function is a line, and all linear functions, all linear equations are functions. Any linear equation would be a function. There is no way to draw a line that would not pass the vertical line test. I keep jumping around today, sorry. Let's look at another equation. What if we have an equation y squared equals x? Now if I try to set up a table of values, if I plug in 16 for x, y could be 4, because 4 squared is 16, looking back at our equation, but it could also be negative 4. As a matter of fact, this function looks like this. Shouldn't say function. This equation looks like this, and this does not pass the vertical line test. Therefore, this is not a function. Okay? So we sometimes will look at functions written as equations. Now we're going to talk about something called function notation, and this is really, really important. It's a brand new concept, but I don't think you did it in pre-algebra, but possibly you touched on it. So function notation. This is a new way of writing our equations. So if we have the equation y equals 2x plus 1, another way to write this is to use function notation. Instead of y, I'm going to put this symbol. Now, this symbol is read f of x, or we can say that this means function of x. This does not mean multiplication. This symbol does not mean f times x. Do not get in the habit of thinking that this is a multiplication problem. Okay, we talked a long time ago that this notation talked about the fact that y depends on x. We also said y is a function of x. So that gets translated into this function notation. Okay, f of x or function of x. F of x, the function of x, and y are interchangeable. Now, how and why do we use this function notation? So if I have a function, let me erase this a little bit here. If I have a function f of x equals 3x plus 2, what that is saying is that I have some y value that is a function of x, and the function is found by multiplying x times 3 and adding 2. Now, if I want to find a particular value for this equation, The old way would be to say y equals 2x plus 1, and we would say find y. Whoops, I should do the same function. Sorry, let me erase this. So y equals 3x plus 2. We would say find y when x equals 1. And you would say y equals 3 times 1 plus 2, so y equals 5. Function notation is much simpler. If I want to find the function value, the function of x, when x is 1, I simply say find f of 1. And what I do then is every place that I had an x, I substitute a 1. So if f of x is the function that takes 3 times x plus 2, then f of 1 is the function that says 3 times 1 plus 2. So if I want to now find, let's say, f of negative 3, that would be 3 times negative 3 plus 2. I'm sorry, I should have put equals 5 next to that. And this would equal negative 9 plus 2 is negative 7. So this does a few things for us. Let's take a look at this a little bit closer. So if I have a function, and I'm going to use the old notation for a minute. If I have two equations, y equals 2x minus 1 and y equals x plus 4. And I want to, find a bunch of values for a table. I want to do x equals 3, x equals 4, x equals 1. So over here I'm going to do y equals 2 times 3 minus 1, which is 5. So y equals 5. I'm going to do y equals 2 times 4 minus 1, which equals 7. So y equals 7. And I'm going to do y equals 2 times 1 minus 1, which is 1. So I used these three values in my first equation and found three y values. If I do the same thing in this equation, y equals 3 plus 4, so y equals 7. Y equals 4 plus 4, so y equals 8. And y equals 1 plus 4, so y equals 5. So I've got 6 different y values that came from 2 different equations by plugging in 3 different x values to each equation. And I have to take some time to go back and think about how do these things match up to each other. If I use function notation and I call my first function f of x equals 2x minus 1, and I call my other function g of x. So normally we start with f of x for our first choice, g of x for our second, and then we could use h of x or other things as well. So g of x is going to be my x plus 4 equation. Now, if I use same three values, f of 3 equals 2 times 3 minus 1, so f of 3 equals 5. F of 4 equals 2 times 4 minus 1, so f of 4 equals 7. And f of 1 equals 2 times 1 minus 1, so f of 1 equals 1. Then if I do the same thing over here, g of 3 equals 3 plus 4, so g of 3 equals 7. G of 4, equals 4 plus 4, so g of 4 equals 8. And g of 1 equals 1 plus 4, so g of 1 equals 5. Take a look at these 6 values, compared to the 6 that I did over here. This gives me a whole lot more information. Not only does it tell me which function I plugged into, f of x or g of x, as opposed to these are all just y equals, it also tells me what I plugged in. The function f, evaluated when x is 3, is 5. The function f, evaluated when x is 4, gives me 7. And the function f, evaluated when x is 1 gives me 1. So in essence, this gives me the ordered pair very clearly. The same thing for my g function. Okay, we'll do a little bit more of this together in class before we move on, but that's the main idea of functions.